Example 2. Sidebar. Figure 7 shows the surface of a revolution whose area is computed in example 2. There is a point 1 and 1 and a point 2 and 4 along y equals x squared, forming a conical shape parabola. Back to the text. The arc of the parabola y equals x squared from point x equals 1 and y equals 1 to point x equals 2 and y equals 4 is rotated about the y-axis. Find the area of the resulting surface. Solution 1. Using y equals x squared and dy over dx equals 2x, we have formula 8. Big S equals the integral of 2 pi x dx equals the integral of 1 to 2 of 2 pi x times the square root of 1 plus open dy over dx close it squared dx equals 2 pi the integral from 1 to 2 of x times the square root of 1 plus 4x squared dx. Substituting u equals 1 plus 4x squared, we have du equals 8x dx. Remembering to change the limits of integration, we have big S equals 2 pi, the integral from 5 to 17 of the square root of u times 1 over 8 du equals pi over 4, the integral from 5 to 17 of u to the power 1 over 2 du equals pi over 4, open bracket, 2/3 u to the power 3 over 2 close on the interval from 5 to 17 equals pi over 6 times open 17 times the square root of 17 minus 5 times the square root of 5 close. Solution 2. Using x equals the square root of y and dx over dy equals 1 over 2 the square root of y, we have big S equals the integral of 2 pi x ds equals the integral from 1 to 4 of 2 pi x times the square root of 1 plus open dx over dy close squared dy equals 2 pi the integral from 1 to 4 of the square root of y times the square root of 1 plus 1 over 4y dy equals 2 pi the integral from 1 to 4 of the square root of y plus 1/4 dy equals pi, the integral from 1 to 4 of the square root of 4y plus 1 dy equals pi over 4, the integral from 5 to 17, the square root of u du, where u equals 1 plus 4y equals pi over 6, open 17 times the square root of 17 minus 5 times the square root of 5, as in solution 1. Sidebar. As a check on our answer to example 2, notice from figure 7 that the surface area should be close to that of a circular cylinder with the same height and radius halfway between the upper and lower radius of the surface. 2 pi open, 1.5 close, open, 3 close equals, it can be reread as 2 pi times 1.5 times 3 equals approximately 28.27. We computed that the surface area was pi over 6, open 17 times the square root of 17 minus 5 times the square root of 5 close, which approximately equals 30.85, which seems reasonable. Alternatively, the surface area should be slightly larger than the area of a frustum of a cone with the same top and bottom edges. From equation 2, this is 2 pi times 1.5 times the square root of 10 is approximately 29.80. Back to the text. Example 3. Find the area of the surface generated by rotating the curve y equals e to the power x, where 0 is less than or equal to x and x is less than or equal to 1, about the x-axis. Solution. Using formula 5 with y equals e to the power x and dy over dx equals e to the power x, we have big S equals the integral from 0 to 1 of 2 pi y times the square root of 1 plus open dy over dx close squared dx equals 2 pi the integral of 0 to 1 times e of e to the power x, the square root of 1 plus e to the power 2x dx. Sidebar, another method used formula 6 with x equals natural log of y. Or use formula 21 in the table of integrals. Back to the text. And this equals 2 pi, the integral from 1 to e times the square root of 1 plus u squared du, where u equals e to the power x, which equals 2 pi the integral from pi over 4 to alpha secant cubed theta d theta, where u equals tangent theta and alpha equals the inverse tangent of e, which equals 2 pi times 1/2 open secant theta tangent theta plus the natural log of the absolute value of secant theta plus tangent theta, close bracket, on the interval from pi over 4 to alpha by example 7.2.8, which equals pi open bracket secant alpha tangent alpha plus the natural log of secant alpha plus tangent alpha minus the square root of 2 minus the natural log of square root of 2 plus 1, close bracket. Since tangent alpha equals e, we have secant squared alpha equals 1 plus tangent squared alpha equals 1 plus e squared, and big S equals pi open bracket e to e times the square root of 1 plus e squared plus the natural log of open e plus the square root of 1 plus e squared close minus the square root of 2 minus the natural log of open the square root of 2 plus 1 close bracket.